Hi everyone, welcome to Lecture 2 Part 1 on simple and complex statements. Now, since this is the first video, I'll explain what I'm going to do next now. So at the start of each video, I'll state the objectives for that video. That way it helps keep track of where we are at any one time in the video and what we're aiming for. So if you're pausing the video to take notes, for example, and get bogged down or lost, then referring back to the objectives from the start can help resituate yourself. So the objectives for this video are the following things. After watching, everyone should be able to: Number 1, define simple and complex statements. Number 2, describe the structure of simple and complex statements. And number 3, identify whether a given statement is simple or complex. Now, these are the topics covered in sections 1.1 through 1.3 of the book, although section 1.3 also covers truth tables, which I'm going to do in a separate video. So while there are no formal prerequisites for this course, if you've taken any of LPS 29 or 30 in the past, a lot of this material from the beginning is probably going to be very familiar. So the title of this class, right, is Inductive Logic. But despite the title, we're going to start by focusing on the logic of and, or, and not, so those three words. And that's deductive logic. Now, there are two reasons why we would do that. One is because one very broad goal of this course is for people to understand the differences between deductive and inductive logic. So when we do meet inductive logic, in not very many lectures' time, since we'll have seen deductive logic, we'll be able to compare those two kinds of logic together. The second reason is that later on in the course, when we look at some of Mill's methods, the deductive logic stuff we begin with here is going to be useful to us. So deductive logic is broadly where we begin. Now, since we'll be interested in the grammatical structure of the logical connectives I just mentioned, so and, or, and not, it's going to be useful to first define a few terms. So we start by looking at what happens when we say we make a definite claim. Now, one way of making a definite claim is to express two things. First, you identify something or someone that you're talking about, and then second, you make a claim about it or them. An expression that does the first of these things, that is, an expression that identifies what it is we're talking about, is called a referring expression. That's definition 1 here. An expression that does the second of these things, that is, an expression that makes a factual claim about the referent of the first expression, is called a characterizing expression, and that's definition 2 on the screen there. So let's look at an example. The sentence you can see reads, "The coffee cup is blue." It makes a definite claim and it consists of two expressions. First expression is the coffee cup. This expression identifies what it is that I'm talking about. So by definition 1 from the last slide, it's a referring expression. The second expression in that sentence is blue. Now this expression makes a factual claim about the thing that I'm talking about the coffee cup. So by definition 2 that we just saw, it's a characterizing expression. Now, the thing we're going to do next, we're going to pause for a question so you can all have a go yourselves. Now, mostly what will happen with these questions is that the video will pause, you'll see some options or a prompt, you will answer, and then you'll click continue. Now, a lot of the time, I won't go through the answers in the video because if you reuse the video for study purposes, I don't want people just remembering the answer from last time. That won't be much use to people. It's better to properly test yourselves while you're going through this stuff. I can talk about any of the questions in the large group meetings though, so that's the time to ask me about the answers if you're stuck on any. The exception will be when I'm going through a proof or something like that, which we'll do later on in the course, where I ask you to fill in some steps as we're going along. It's important in those cases that everyone is on the same page as we go along through the video. So I will say what the right answer to the questions is there. But for the most part, once you answer the question and click continue, the video will just go back to me talking about the next thing afterwards. I can see all of your responses, so if there's major points of misunderstanding, they'll be flagged. I'll be able to see that, and then I can say something about them in the large group meetings. So with that, here's your first question. Okay, so we've seen that a referring expression and a characterizing expression can be used together to make a definite claim. We then say that a statement is a sentence that makes a definite claim. And stronger than that, we say that a statement is a simple statement if it consists only of a referring expression and a characterizing expression. The example we just saw, the coffee cup is blue, is a simple statement by definition 4 from that last slide. Now here's another example of a statement. The body of the coffee cup is blue and the handle of the coffee cup is orange. Now what do we notice? We notice it's a statement by definition 3 from the last slide because it makes a definite claim. In fact, it makes two, that the body of the coffee cup is blue, which is a definite claim because it contains a referring and a characterizing expression, and that the handle of the coffee cup is orange, which is a definite claim for the same reason. However, this sentence also contains the word and. Now, the word and is neither a referring statement, it doesn't fit definition 1 from all those slides ago because it doesn't identify anything, nor is the word and a characterizing expression. It doesn't fit definition 2 from all those slides ago because it doesn't make a factual claim about anything. So the sentence we can see on the screen, while it is a statement, is not a simple statement because it does not fit definition 4. It does not consist only of a referring and a characterizing expression. You've got this extra thing in there, the word and. Now we'll pause again for a question here. Okay, next thing we're going to do is look at characterizing expressions in a bit more detail, and these things called predicates. Now, there is more than one kind of characterizing expression. If a characterizing expression characterizes an individual thing, so one thing, then that expression is called a one-place predicate. The book also calls it a property expression, but I'm going to try to stick to the language of predicates in my lectures. If, on the other hand, a characterizing expression characterizes two or more individual things, so more than one thing, then that expression is called an n-place predicate, or a many-place predicate. The book also uses the term relational expression, I think, for that. But I will try and stick to the predicate language for this too. Now, the many here, or the n, is determined by how many individuals are referred to. So if a characterizing expression relates two individuals, we'd call it a two-place predicate. If a characterizing expression relates 17 individuals, we call it a 17-place predicate, and so on. I've defined it in the slides as an n-place predicate, where n is used in place of many. N, of course, is just the number of things that the characterizing expression relates. Now, if we go back to our favorite example, the characterizing expression is blue in the coffee cup is blue is a one-place predicate, sometimes called a unary predicate too, because it characterizes an individual thing. It's just one coffee cup that it's talking about here. On the other hand, let's look at this sentence. Tom and Hannah are brother and sister. Now here the characterizing expression is are brother and sister. This expression describes a relation about the two individuals, Tom and Hannah. So we'd say are brother and sister is a two-place predicate, or sometimes called a binary predicate. We're going to pause here for another question. Good stuff. Now, so far, we've seen how we can build simple statements from referring and characterizing expressions. And here, the words that I mentioned all the way back at the start, and, or, and not, they kind of come into the picture properly. Now, we said earlier that and doesn't fit the definition of a referring or a characterizing expression, which is why a statement, if it involves the word and, cannot be a simple statement. The same can be said if we had replaced and by or if we had used the word not in the appropriate place in that example we saw. So instead, and, or, and not are different kinds of things, and we call them logical connectives. Now, using logical connectives, we can build complex statements from simple statements, and indeed that's all we really mean by complex statements. So definition 7 here says complex statements are statements constructed from simple statements using the logical connectives and, or not. So the example I used earlier then, the body of the coffee cup is blue and the handle of the coffee cup is orange, is a complex statement because it satisfies definition 7. Now we're going to be interested in general in when statements of various kinds are true. For simple statements, this is straightforward. A simple statement, remember, consists of a referring expression and a characterizing expression. So we say that a simple statement is true or correct when the characterizing expression correctly characterizes the thing or things that it refers to. The first example simple statement we saw, the coffee cup is blue, is true in this case, because the characterizing expression is blue correctly characterizes the coffee cup to which it refers. So how do we tell when complex statements are true? We can do it for simple statements. How do we do it for complex statements? Well, we've seen that complex statements are built from simple statements using the logical connectives and, or, and not. And so the truth or falsity of complex statements depends on two things. It depends on the truth or falsity of its simple constituents and the way that they are combined using those logical connectives. Now, one of the other examples we've seen, I'm sure you'd all say, is obviously false, this one. The body of the coffee cup is blue and the handle of the coffee cup is orange. It's clearly not orange. Now, truth tables are a way of making precise why this complex statement is false. And so we're going to stop this video here and we'll carry on with truth tables in the next installment. Now, the last thing I'm going to ask everyone to do is answer one more question. You'll have to do this at the end of every video. It just asks you to rate how comfortable you were with the video material that you've seen here. So you'll have a scale from 1 to 5. There are no wrong answers. 1 means I was comfortable with absolutely none of it. It was all horrible. And 5 means everything was perfect. I understood everything really well. So we'll pause for that question and then the video will stop.